This is our 60% submittal presentation for the Autobot Body Shop Development Project, which has been prepared for Murrayville, Georgia. We are GCB. Today we'll go over our team, the project scope, the discipline scope, our site location, the design alternatives we came up with, what we decided to go with, our site plan, and then we'll get into the major specifics, which are hydrology, structural, and transportation, along with the cost estimate for the project. I'm Garrison Smith. I'm the project manager and the structural design lead.
I'm Colin Kane, and I'm the transportation design lead and the cost estimator.
I'm Blake McMichael, and I'm the senior design team lead, the hydrological engineering lead, and the environmental consultant.
Basically, our project overview would be construction of a 2,800 square foot, one-story auto body shop that would include a parking lot and a driveway on 0.61 acres of commercial site located in Murrayville, Georgia. The auto body shop will feature 3 service bays that can accommodate passenger vehicles like commercial vehicles and medium duty trucks. The purpose of development is to support local economic growth and meet the increasing demand for vehicle repair services. Our phase deliverables will be the 30%, 60%, 90%, and our final design submissions. And the goal for this project would be to deliver safe, functional, and code compliant facility for community use. The structural component of this project will include the selection of building materials, determining the structural design criteria, providing structural calculations, and also structural construction drawings.
For transportation, we'll be making a commercial driveway to GDOT specifications along with parking space design, which includes a parking study of a similar sized building, a traffic impact study, the pavement design, and the permits needed for everything.
For the hydrology, we'll be creating a pre-development conditions map, along with a post-development and a hydraulic analysis, where we will show the stormwater management systems and the hydraulic analysis, as long as a grading plan. We are also doing an environmental impact study and a project cost estimate.
Our location is 5323 Thompson Bridge Road in Hall County, Georgia. So our design had 3 different alternatives. The first one, with the building in the rear, had 12,500 square feet of pavement, cost around $62,000. However, there was no space for a detention pond, so we ended up not going with that. The building for design 2, the building was in the front but sideways and would have had 11,000 square feet of pavement with a $55,000 cost, which it does have space for a detention pond. And for our third design, the building's in front, parallel with it, with only 10,000 square feet of pavement, making a $50,000 cost, with the space for a detention pond and less grading needed. So we chose the third design since the building was easily visible from the road, had the cheapest pavement option. You were able to put in a detention pond since that'll be the cheapest option for water storage, and has the least amount of grading since the parking will be in the front and not the back. And then this is our site plan.
For the environmental impact study, auto body shops in Georgia must comply with the EPA Environmental Protection Agency Rule 6H, requiring all initial notifications for paint, stripping, and coating activities to the Georgia EPD, and EPA Region 4. Typical automotive facilities routinely generate a variety of waste materials such as oils, solvents, paints, antifreeze, batteries, and cleaning residues. If these are improperly managed, they can cause risk to the public and the environmental health. Some ways that this can be controlled is capture the air pollutants via enclosed spray booths and filters, properly store and dispose of hazardous waste through licensed vendors who are designed to take care of that specific waste, prevent water contamination via controlled wastewater handling, such as like an oil separator for automotive fluids, train staff and maintain records for full regulatory compliance, and report to Georgia EPD and EPA Region 4 as required. This is our pre-existing condition. The base outline is a 0.61 acres as discussed earlier. It also consists of a concrete driveway that already exists there that will be demolished. For the pre-development, some of the existing conditions is there's 2 pre-basins. Pre-basin A has 0.68 acres of open space. Soil group B in good condition, giving it a curve number of 61 and a time of concentration of 13.2 minutes. Pre-basin B, 0.78 acres of open space, also soil group B in good condition, and there's also a curve number of 61. But it also has a 0.11 acre of impervious land, giving it a total of 0.89 acres with a composite CN of 66 and a time of concentration of 12.6 minutes. This is our pre-development map. The red line is going to show the pre-basin A, and the pink for pre-basin B. The green arrows show the flow of water from our high point at roughly 1288 elevation all the way to our low point at these study points, as you can see going towards the arrow. For the site grading is important because it ensures it is properly drained and the site functions properly. For this site, the grading plan ensures proper drainage of stormwater and detention to the detention pond located behind the building, the curb inlets at the front of the parking lot, and then the proposed grading plan makes certain that the site is stable slopes and smooth transitions between areas, making it safe and easily accessible for vehicles, pedestrians, and proposed structure. Our proposed grading roughly has 223,000 cubic feet of cut that needs to occur and 119,000 cubic feet of fill. This is our grading plan. The green dashed line represents the new proposed grading. The 80 with the detention pond starting at an elevation of 1280, and it goes down in increments that I will discuss later. For the post development, there's a single post basin with 0.58 acres of open space with a soil group B in good condition of a curve number of 61. It also has a 0.28 acres of impervious area with a curve number of 98, giving a total area of 0.86 acres and a composite CN of 73 with a time of concentration of roughly 12.1 minutes. There are also 2 bypasses, bypass north and bypass south. The bypass north consists of 0.08 acres of open space, also soil group B and in good condition. It has 0.05 acres of impervious area with a total area of 0.31 acres, a composite CN of 36, and due to the small acreage, it can be assumed that the time of concentration is 5 minutes. The same goes for bypass south that also has a 0.31 acres of open space, CN of 61, however, and a TC time of concentration of 5 minutes can also be assumed. This is our post-development map with the blue dashed line representing the post basin, with the gray lines determining the post bypass, both north and south. EMP drainage design. So the detention is 6 feet, and it has a slope of 2 to 1 height to vertical. The max storage that it is attained to hold for a 100-year storm event is 16,109 cubic feet. So using that information, I was able to design an outlet control structure with a culvert, which is going to be the big outlet pipe uh, with a this is an 18 by 18 inch with a length of 54 feet at a 1% slope and an invert elevation of 1274 at the bottom of the pond. The water quality orifice was designed to hold up to the water quality needed to be roughly around 1284 cubic feet. So it was designed at that span with a rise of 1 inch by 1 inch with an invert elevation of 1274. The channel protection orifice is located at the rise span of 2.25 inches with also that span with an invert elevation of 1275.9 feet. The two weirs located at the top of the outlet structure is a rectangular shape with a crest elevation of 1276 feet, crest length of 1 in height. Weir coefficient is 3.33, and it is multi-stage, and the same can be said for the other weir, but it is at a crest elevation of 1277.53 feet, crest length of 16 feet, and a weir coefficient of 3.33, and it is multi-stage. For our storm sewer design, we have two curb inlets located at the front of the property with 16-inch pipes connecting the two curb inlets located at the two low points. And these pipe run from the front of the property all the way to the back, all exiting into the existing the detention pond through a head wall. The pipe length is roughly 315 feet. And all hydrology and output reports are presented in the report for 1 year, 1 through 100-year storm events. And this is just a basic model of what our design is. So 4 here is labeled going to be our pre-basin. All the water there is going to flow through our detention pond and then out to our study point, while 6 is representing the bypass south, and that's going to run straight to our study point. And then 7 is going to be the bypass north, and that runs directly towards our study point in the north front part of the lot.
For the structural system, we decided to go with steel because it will provide it works great in wide open work areas with increased ceiling height, which would be required for the auto body shop to accommodate vehicle lifts and heavy equipment. Steel can also be fabricated off-site, which will help reduce the labor cost and eliminate on-site farm work and minimize weather delays. Along with that, steel also reduces construction time. It lowers the foundation cost, and long-term adaptability of it makes it the most cost-efficient solution. For the codes used to design the structural was ASCE, AISC, ACI, and IBC. For design assumptions, the structural design will consider dead, live, and wind loads in accordance with ASCE 722. Seismic and other natural hazards are acknowledged but are excluded from the detailed design to limit the project scope. The ASCE hazards report summarizing all applicable environmental hazards is included in Appendix A of the report. The building is classified as Category 2 in accordance with ASCE 722. And in order to obtain the soil bearing capacity, we looked in the IBC and we got 3,000 PSF due to the lack of a geotechnical report. Here we have the summary of all the design loads: floor, roof, wind loads, floor, roof, and wall loads, which include live loads. For the floor, for the roof, there were live loads, dead loads, and wind loads. For the wall, there were dead loads and wind loads. some of the loads came from AFC, the other loads were obtained from the vendor manuals, and for the Wetland loads, they were calculated in accordance with ASC 722. Here we have the preliminary structural framing plan, which shows the column sizes along with the locations. One thing to note is that the columns will be HSS columns, which would be 12 by 12 by 5/8. Here we have the roof framing plan, which shows the preliminary beam sizes for all the roof members. The strength of the structural members was evaluated using SAP 2000 software. The load combinations were developed in accordance with the ASC 716. Structural members were analyzed and designed in accordance with AISC 36016. The governing band capacity ratios are all less than or equal to 1, indicating that all the members satisfy the required strength criteria. The full summary data for that is provided in Appendix A of the report. The deflection of the primary structural members were also evaluated with SAP 2000. The mid-span vertical displacement was used as the maximum beam deflection under the governing surface load combinations. These deflection were then applied compared with the allowable limits, which is specified in AISC 36022. The full deflection summary data is also provided in Appendix A of the report. Here we just have some bits from the full tables. The full tables are again included in Appendix A. Here we have the demand to capacity ratio table, which is on the left, and the deflection table, which is on the right. As you can see, all our structural members pass both the strength and serviceability requirements. For the 9% submittal would be for structural would be the slab design, foundation design, and a complete set of structural drawings, including elevation views, section views, and a final framing plan with member sizing. To the right, you can see in progress elevation views of the front of the building, which include the 3 server bay doors. You can see elevation view of the right wall and elevation view of the front wall, which are all works in progress right now.
For transportation, this was our final site layout. In it, you can see the 19 parking spots, the 1 ADA spot with van loading. You can see the GDOT driveway. We also added a dumpster, as well as the sidewalk in the yellow on the right side leading to the entrance. There's also a curb and a gutter across the whole thing and going down the driveway to help the water run. When deciding what to use, it was between asphalt and concrete. Asphalt has a lower initial cost, it's easier to repair, and is for low to medium traffic, while concrete is more expensive, but has a longer lifespan and is better for heavy loads. And then we chose asphalt since it was cheaper, and we're only going to have low to medium traffic, so it wouldn't really be needed. Concrete wouldn't be needed. For our pavement design, this were the parameters used in PCASE based on a 20-year life cycle. The passes for each vehicle type were based on the traffic study and has 3 main targets: 2-axle trucks, large vehicles, and small vehicles, as you can see here. So large 2-axle trucks had 7,300 passes, where large vehicles had 65,000, and small vehicles had 372,000. And this is what we got. We got a asphalt cement of 2.5 inches, a base of 6.5, and a cohesionless cut of 4 inches, as you can see in the diagram here. For For designing our driveway, we had three options. A standard turn-in, no flares, but those were only used for residential buildings and not for busy highways, so that was quickly thrown out. We have a flare driveway used for commercial buildings. It's a balance between a turn lane and no turn lane and has a mid-range cost. And then the third option was a driveway with a deacceleration lane, and those are used for commercial buildings, but only for busy buildings, and they're super expensive. So we chose the flare driveway since we didn't need all that, and has a 24-inch interior radius with a flare of 35 feet. It's cheaper than the deacceleration lane and not needed with the small amount of traffic we'll be getting, and it must connect with the existing sidewalk already in the road. This is the driveway specifications. You can see it's 24 feet long with 85 feet at the end, has a 35-foot radius. Now you can see the driveway, the sidewalk on there, and has a 6-inch curb with an 8-inch base made of 3,000 PSI concrete. The sidewalk ties in, and this is a cross section of the driveway. And then for my 90% submittal, the site plan, including all the signage and striping that goes along with it, the ADA ramp specifications that are going into the sidewalk, the sidewalk design leading up to the building, and then just to finalize the report.
The cost estimate at 60% right now is $411,000. The cost estimate previously at our 30% was $567,000, giving us a net savings of $153,380. This has been our 60% deliverables presentation.
Let's build something great.
Thank you.
Thank you.